Today's notes, I'm going to show you 4 examples on how you can factor using a GCF. GCF stands for greatest common factor. And again, there's different types of factoring methods. This one I'm going to usually start with first, because if you can do a GCF factoring, that's always best to start with that. And again, which type of factoring you use will always depend upon what type of expression you're working with, okay? So we're going to start with, like I said, GCF, greatest common factor. What you want to look for in this type of factoring is, again, something that they have in common in all the terms. All right, so I've got a couple different examples showing you different things to look for. So the first example I have here, we're just going to look for a number that they have in common. All right, so I have an expression that says 5x plus 10. So when you look at this expression and you're thinking of numbers, multiplication tables, division, things like that, what's a number that is a factor in both the 5 and the 10? So again, what number can you divide into 5 and what number can you divide into 10? Okay, that's what you're thinking. All right, so seeing both of these, I know that both of these numbers can be divided by 5. Okay, so my GCF is going to be 5. So what you want to think is, okay, I'm going to divide both of these by my GCF, which is 5. All right. So then what we're going to do, I'm going to go ahead and I'm going to put the GCF, I'm going to write that down, which is 5. And then I'm going to draw a little set of parentheses here. And what we're going to do is, just one at a time, we're going to divide each term by that 5. And when I'm done dividing, I'm going to write my answer inside the parentheses here. All right, so if I take a 5x and I divide it by a 5, 5 divided by 5 is 1. That would leave me with the x. And you could put a 1 in front of that if you'd like. Then there's a plus sign, so I'm going to go ahead and put my plus sign. And then I have 10 divided by 5. 10 divided by 5 is 2. Okay, so we have now factored that using our GCF. Our GCF is written out here in front. We divided both our terms by the GCF, and then inside the parenthesis is the result of that division. Okay, one way you can check your answer when you're dividing and doing your GCF is just to kind of quickly do a little distributive property to make sure that you didn't do any division wrong. So again, if I were to take 5 times x, that would give me 5x. 5 times 2, that will give me the 10, and you can kind of do a quick check just by doing that distributive property. All right, so that's an example that had a number as a GCF. Sometimes you might have a variable as a GCF. All right, so in my second example here, we have 3x to the third plus 2x squared. All right, and again, if we look at the numbers, 3 and 2, they don't have any common factors. So there's really nothing I can do with that, kind of like I did up here with the 5. Okay, so there's no numbers in common. However, this one, we notice, hopefully, there's some variables in common. This one has an x to the third, and this one has an x squared. Okay, so again, if they're in common, you know, how many do they have in common? Okay, both of these have at least an x squared. Okay, so for in this particular problem, my GCF is going to be x squared. Okay, so again, what you want to think about is dividing, in this case, both terms by our GCF, which is x squared. Okay, and you can write it out like this if you want. After a while, and you do quite a few of these, you might be able to do that in your head without writing it out, but this is what I want you to think of visually. You're dividing each term by that GCF. All right, so again, for my answer, I go ahead and I'm just going to copy down that GCF out in front. I'm going to draw my little set of parentheses here. And again, if I started with 2 terms, there should be 2 terms in my parentheses. Just like here, I had 2 terms, and I have 2 terms inside my parentheses when I was done dividing. All right. So if I'm going to divide here, I have a 3. I'm not dividing by any numbers, so the 3 is just going to kind of stay there. And here I have x to the third divided by x squared. Okay, so if I have x times x times x, and then I'm dividing by 2 of them, x times x, that's going to leave me with 1x. Okay, And then I have a plus sign. I'll go ahead and put that. Again, there's no numbers that I'm dividing by. I'm going to copy down the 2. And if I have an x squared divided by x squared, this would just become 1. All right, so I just have 2. I don't need to write a 1 with it. Okay, so again, I started with 2 terms. I have 2 terms inside the parentheses with my GCF written out in front. And again, we could kind of do a quick little mental check here to see if, make sure we didn't do anything wrong. If I take x squared times 3x, that will give me 3x to the 3rd, which is what we had over here. If I take x squared times a positive 2, that'll give me a positive 2x squared, which is what we had here. So that's kind of a quick little check. All right. Okay, let's see. Third example. My third example here, this one has both a number and a variable in common as far as my GCF. So again, it just all kind of depends upon what's going on in that problem with those coefficients and those variables. So just take a look and see what you have. So if I look at the numbers in this problem, we have a 7, we have a 14, and we have a 21. Okay, all of those have a common factor of 7. Okay, then if I look at my variables, I have an x to the 3rd, I have an x squared, and I have an x. So they all have at least an x in common. Okay, so our GCF for this problem is going to be, they all can be divided by 7, and they all have at least one x. Okay, so my GCF is 7x. All right, I'm going to go ahead and we're going to divide each term one at a time by our GCF. So my original problem, I had 7x to the 3rd minus 14x squared minus 21x. Our GCF, we're going to divide everything by 7x. All right. So again, I'm going to write my 7x out in front. Now, just like before, since this problem has 3 terms inside my parentheses, I should have 3 terms as well. So again, whatever you start with, you should have inside that set of parentheses there. All right, so one at a time, we're going to go ahead and we're going to divide. So 7 divided by 7 would just be 1. X to the 3rd divided by an x would leave me with x squared. There's a minus sign. I'll put a minus sign. We have a 14 divided by a 7, which is a 2. X squared divided by x will leave me with just x. I have another minus sign. 21 divided by 7 is 3. And then x divided by x would just become a 1. So those x's would be gone. And close off my parentheses. So again, GCF written out in front. 3 terms inside from when I divided by the GCF. All right. And then the last one here, let's see. Sometimes there's a negative sign out in front here, and usually we don't kind of like that hanging out there. So in this particular problem, if there's a negative sign in that leading term, I would usually divide a negative as far as a common factor or use that with my number. In this particular one, as far as, again, I would look at the numbers first and see if they have anything in common. I see a 8, I see a 24, I see a 16, and I see a 4. All right. So as far as a greatest common factor, I do believe all of these can be divided by 4. And again, like I said, since there's that negative leading out in the front there, I'm going to use a negative 4 as part of my GCF. So I'm just going to go ahead and put my negative 4 for all of these. If we take a look at the x's, I believe we're going to have some x's in common as well. Here we have negative 8x to the 5. We got 28x to the 4. We've got 16x to the 3rd, and then 4x squared. Okay, so again, they all have at least an x squared, so we can use our x squared in our GCF as well. Okay, now again, this expression had 4 terms. So again, when I'm done, I should expect that I should have 4 terms within my parentheses. And then again, out in front, I'm going to go ahead and write my GCF. So I'm going to go ahead and write my negative 4x squared out in front. And then again, one at a time, we're just going to divide each one of these, writing our results inside our set of parentheses. Okay, so here we have a negative divided by a negative, so that'd be a positive. 8 divided by 4 would be 2. I've got x to the 5 divided by x to the x squared. That would leave me with x to the 3rd. Positive divided by negative would be a negative. 28 divided by 4 would be 7. X to the 4th divided by x squared would be x squared. Negative divided by negative is positive. 16 divided by 4 is 4. X to the 3rd divided by x squared would leave me with just x. And then lastly, we have a positive divided by a negative, which would be a negative. 4 divided by 4 would just leave me with 1. And then x squared divided by x squared would also just be 1. Don't need to write it again. All right, so again, here's my GCF, my negative 4x squared on front, and then inside, I've got, again, my 4 terms. Okay. And again, you could quickly just do a little distributive property, multiply out, make sure you didn't do any division wrong with your numbers, check your signs, check your exponents. X squared times x to the 3rd would give me back to x5. X squared times x squared gets me back to x4. X squared times x gets me back to x3. And then here my negative 4x squared times a negative 1 would get me back to my positive 4x squared. All right, so there you go. 4 good examples on how you can factor using a GCF. All right, good luck with that homework.